Hello friends. So today's topic is work and energy. So I am going to whole chapter, okay? The basic things and the most important things of this chapter, okay? I will discuss about work and energy, okay? So what is work? Work is usually we use this word in non-scientific method, okay? We don't consider the scientific approach, okay? But whenever body moves, it is doing work. When car is moving, it is doing work, right? So everything seems to be doing work when motion is there. So in the scientific part, the most important thing is we know that force. Yeah, we know force is something which when we apply on a body or objects it moves, right? Or moving body, when we apply to the on a moving body, the objects or body tends to decrease its speed, and after a certain time it gets zero velocity or zero speed, right? So that is the force. And here you can see s is the displacement or the distance covered by the object or substance, okay? So when we apply force, suppose that a static body is there, this is standing, and we applied a force of amount f. So now what will happen, the body may move to a certain distance. So if distance is s, then the movement of the object is s, so the work done is the f into s, means force into displacement. So this is the basic work, okay? We know the unit of force, that is newton in SI unit, and in CGS unit it is dyne. And for displacement, okay, for displacement it is the length. The unit is obviously in the SI unit it is meter, and in the CGS unit it is centimeter, okay? So see, so wait 1 second, the formula I am searching for, okay? So here you can see the work done is equals to F into S. So work done is equals to F into S, means applied force into displacement. When we suppose we applied a 10 Newton force on an object and the displacement is 5 meter, so ultimately the work done will be 10 into 5 means 50, okay, 50. And the SI unit of the work done is joule, and CGS unit is arg, okay? So we know that 1 joule is equals to 10 to the power 7 arg, okay? So this is the work done, okay? Now we are going to energy. So energy is what, when we have energy we can do work. We say it in daily life, right? When the body has a energy, it can do some form of work. This is the energy, okay? And many forms of energy are there. Maybe it is electrical energy, okay, atomic energy, okay, heat energy, yeah, heat energy as well, or something like chemical energy, mechanical energy, okay? So in mechanical energy, what can they do? Mechanical work can be done, right? So many forms of energy are there. The most of the energy source is the sunlight, that is light energy, right? So we are discussing now kinetic energy. So kinetic means movement, okay? It is related with kinesis, means movement. So whenever kinetic energy refers to the energy that deals with or that is associated with the kinetic or the motion of a body. When body moves or in a motion, it has some amount of energy. So this energy we need to measure, and we measure this energy as kinetic energy is equals to half mv square. So half m into v square. Here m is the mass of the object, okay, and v is the velocity of that object. So a body of mass m is moving with a velocity v, so its kinetic energy will be half m v square, okay. So kinetic energy is a form of energy, so the unit is obviously in SI it is joule, and in CGS it is arg, or sometimes calorie also, okay. So she, okay, so this formula I think you will know. S is equals to v square minus a square by 2a. Actually it came from the v square is equals to u square plus 2as, means v is the final velocity v, initial velocity u, and the distance covered by the object is s, and the acceleration a. Then we have v square is equals to u square plus 2as, okay. So we know F is equals to ma, means force applied is equals to mass of the object and the acceleration achieved by the object, okay. So see, sorry, so see here one thing is written, work done is equals to half m v square minus a square. What it means, actually, see, in this case an object was there, it had some energy half m u square. U was the initial velocity, and now final velocity is v, so it is increased, okay. So from u to v, so now energy is half m v square, but initial energy was half m u square. So difference of this two energy or kinetic energy, that is the work done, means what we do the work that is stored in the object or body, okay. So that's why the work done is equals to the energy changed. So work done is actually equivalent to the energy gained, okay, or energy used. Okay, this formula I have discussed already. So kinetic energy is half mv square. So next one, okay, wait. So potential energy, this is something like potential you can have some understanding from the word potential, means what is the potency, right? From potency it comes. So actually a object have a specific potential energy, means it can do something, some amount of work, okay. It is stored inside the object, the energy, the amount of energy is stored inside the object, but it is not performing, or it is not uh, using that power, but it is inside the object. So this is the potential energy. How actually potential energy we refer in many aspects. In case of mechanical energy, in the usual case, potential energy the refers to the energy associated with the gravitational force, okay. So gravitational force means a height is associated with the potential energy. When we means from the layer of the earth, when we move further above the earth, so height is increasing. So if height is increasing, then potential energy is increasing, because up to when we are above the earth, we can do some form of work when we are released by some form, okay. So you can see this is the spring. So spring was little bit condensed. When we move stretch it, okay, when we stretch it, then we are storing some form of energy inside this, and that is the stored potential energy. But when we release the external force, means by our hand, sorry, then what happens, the spring again try to constrict, right? So why they are able to do so? This is because the potential energy is stored inside the spring, okay. So next one, So see, this is the usual case. So what they are showing, in the ground, on the ground an object was there, then object was taken away from the ground, and it is kept at a height of h. So now the potential energy of the object will be mgh, means mass of the object, acceleration due to gravity is g, and h is the height. So as high as we take the object, the potential energy will be more high, right? Why? Because the capability to do work of the by the object is increasing as we take it high. Okay, so here is the formula, this one, mgh. Okay, so potential energy is mgh. Sorry. So here another thing, here it is showing. So in the diagram on body, from the place of a, on body is taken to the place of b, path 1. So it is straight line. So the distance or displacement is h. But in the case of second case, it is not taken through straight line, it is somewhat curved, right? So in this case the ultimate height is h. So that's why it will not depend on the path by which the body is taken away. So this potential energy will be same only in both cases. So we need to measure the height from the ground in a straight line way. Okay, yeah. Another thing, another aspects, another reason, in the second case you can see, up to a from place a, the body is taken straight line for a limited distance. After that it is moving horizontally, right? Fully horizontal means it is not doing work. Why? Because the force apply, the force working, force acting on the body is by is fully longitudinal. So the body is taken away from that place. So it is not working when force and displacement, the angle between force and displacement is 90 degree, then no work is done. Okay, so see, in upper part also. Okay, so the angle is important between the acting force and the displacement. If it is 90 degree, then no work is done. So that's why no energy is stored inside the body for doing so. Okay, sorry. So see one thing. So law of conservation of energy. So law of conservation of energy, according to this law, the energy on the earth is constant. Okay, not only earth, the whole universe, the energy is constant. No energy is destroyed or created. It can convert from one state to another, or an one form to another form. Maybe heat energy was there in some place, but heat energy got vanished. How? It is changed to another energy, maybe kinetic energy or mechanical energy, but it is not destroyed. That's why we say that energy is not destroyed or created. Okay, only it can change from one form to another form. Like one body has kinetic energy half mp square, but after some time it don't have kinetic energy. Maybe it is changed to potential energy. Okay, so this is the, so in case of mechanical energy means only kinetic energy and potential energy. So if we see that no other changes occurred, means only mechanical energy is present. So if we see that kinetic energy is decreased, so it is for sure that potential energy is increased. Okay, so sum of the potential energy plus kinetic energy is always constant in case mechanical energy is not converted to any other form of energy. Okay, so see, so rate of doing work on object or on man is working, so at what rate means per unit time how much work is he doing, that is the power of the object or the man. So power is actually work by time. So power is W by T, means work done in time T. So one man doing 5 joule work in 1 second and another man is doing 5 joule work in 2 seconds. So eventually who doing 5 joule work in 1 second is much more potential, much more powerful than second one. Okay, so unit of power is so unit of power is watt. Okay, in the SI unit means 1 joule per second. Okay, 1 kilowatt means 10 to the power 3, kilo means 10 to the power 3 or 1000. Okay, kilowatt, so 1000 kilowatt, sorry, 1 kilowatt means 1000 watt. So if, wait, so here power is denoted as mgh by t, means the work done is mgh, means potential energy is gained in time t, so mgh by t we can write. Okay, I think it is finished. Okay, thank you all.